Hello friends, welcome. Welcome to this presentation from Risingpearl. I'm your friend, your host Roy. Today we are starting a brand new series 2 called Triangles. A lot of you have requested that we start triangles before any other series. So here we are. Webisode number 1 on series 2 Triangles. Friends, today we are going to start off by having a general discussion on comparing geometrical shapes. Right? Let's get started. Now, I'm going to write some numbers. Let's say 5 and 8. Let's say 27 and 32. Let's say 9, 7, 9, 7. The reason I'm writing out randomly pairs of numbers, friends, is that between 5 and 8 there is a relationship. 8 is greater than 5. You can compare the numbers. 27 is less than 32, or 32 is greater than this. 97, they are equal, right? So similarly, if you take any random pairs of numbers, right, it doesn't really matter what it is, and like we often do, we kind of pick things from our imagination and we move on with it. So the idea is that if you have a pair of numbers, we can compare them. We can say if in this case they are equal, that is the two numbers we have, they are actually equal. Here 8 is greater than 5, here 32 is greater than 27, 11 is less than 123, or 198 is greater than 27. So the point is, if we have numbers or numeric values, we can compare them and find out equal to, if they are equal, or if one is greater or less than the other. Now let's extend this concept to shapes. So the simplest shape is a straight line, or we should say a line segment. So here what I have drawn three pairs. Let us call this as the first pair, this as the second pair, and this is a third pair of lines, right? So this line segment, let's say this is let's call it AB, and let us say this measures 10 centimeter, and this line segment is CD, and this measures, let us say, 2 centimeter. And yeah, we are not really using a ruler to measure them. We are just assuming that, if this is the length. So what can we say then? So we can say that AB clearly is greater than CD. By that, what we really mean is that the length or the measure of line segment AB is more than measure of line segment CD. So in this case, let's say this is PQ line segment, and this is RS. So let's say PQ is here 1 centimeter, and RS is, again, let's just call it, this is 15 centimeter. So here we will say PQ, the line segment PQ, is actually less than the line segment RS, right? In this case, friends, we have, let's just call it like XY, and maybe DE. It doesn't really matter what we call them. So, and here let us just assume that this is 7 centimeter, and this is also 7 centimeter. So in this case, what we see is, we see XY, or the measure of the line segment XY, is same as DQ. So friends, we are noticing that if it is a line segment, we can say one is equal to the other, or one is more than the other, or one is less than the other. Now let's continue to expand on this idea, and here we have an angle. In your last class you have seen in great detail about what is an angle, properties of angle, so on and so forth. So angle is formed by joining two straight lines. So here in the first pair, again I have taken three pairs. Let's call that 1, let's call this 2, and this is our third pair. So in the first pair, this is the angle. Let us say this is 30 degrees, and this is also 30 degrees. So let's give it a name. We have AB is a line segment here, AB and C. Let's call this AB and maybe D. So here what we have is, we have angle CAB equal to angle DAB, right? Because they are both 30 degrees. So both angles are equal. Now in this case, let us say this angle is let's say 40 degrees, and this angle is 90 degrees. Let's again name it. Let's call this maybe P, and let's call this as Q. So what we have is we have angle PAB, right? PAB. Now this is 40 degree. The measure of this angle is 40 and this angle is 90 degree. So we will say PAB is less than angle QAB. We can compare again the measurement of two angles, and in this case, friends, again in our third example, let us just say this point is X and this is Y. So we have angle XAB. Clearly this looks like a acute angle. Let's just call this as 20 degrees maybe, and this is an obtuse angle, and let's call this as maybe 120 degrees. So here XAB is less than angle YAB. So friends, what basically we are noticing is that if we have angles, we can compare the measure of the angles. So they can be equal to one another, or one can be more than the other, or one can be less than the other. Let's continue to expand on this idea of comparing the geometrical shapes. Here, friends, we have 3 pairs of circles. 1, 2, and 3. So friends, now this is the first time we are looking at a closed shape, and this is the simplest form of a closed shape, because a line segment or an angle is an open shape. It is not a closed shape. So the simplest form of a closed shape is a circle. Now for circle, how can we compare circle? We know from our earlier class, we looked at in details about what are circles, properties of circles, and I'll actually put a link of those videos underneath here. So we know that circle is really defined by only one thing, which is the radius, which we call r. We represent it by lowercase r. So a circle is defined by the length of the radius, right? So in the first figure I have 2 circles. Let's say the radius here is maybe 1 centimeter, and in this case my radius is, let us say, 3 centimeter. So if I call this as circle A, and we don't really represent circle by alphabets like this, circle B, right? Now normally we do not say that circle A is less than circle B. What we do say is that the radius of circle A is less than radius of circle B. So in this case, friends, here let us say this radius is, let's say, 5 centimeter, and here let us say this is 1 centimeter. Let us say this is circle P and this is circle Q. We do not say that circle P is greater than circle Q. We do not normally say this. No. We talk about radius being more or less, or as you will see in this case, both radiuses are equal, right? Let us just say this is 2 centimeter and this is also 2 centimeter. So here both circles have same radius, and let us just say, well, let's call this circle X, this is circle Y, and we do not again say that X is equal to Y. What we do say is that both radiuses, we do not say this, we say that both radiuses are equal. The other final point we would like to make here is that when it comes to closed shapes, one very simple way of comparing the shapes is that, are the shapes equal, or one is smaller, one is bigger? How do you know? In this case, in the third example, we have these 2 circles X and Y. If you take circle Y and put it on top of circle X, it will exactly completely cover circle X. So then we will say that circle X and circle Y are same or identical, right? And in each of these other cases, that is example 1 and example 2, if you take circle A, put it on top of circle B, circle A is not going to exactly fully cover circle B. you will be, if you put circle A on top of circle B, you will be able to see parts of circle B, from the top, right? Similarly, if you put circle Q on top of circle P, circle Q is not going to cover circle P completely. But in this case, circle Y, if you take Y, put it on top of X, or X on top of Y, each one will cover the other circle completely, fully. So friends, in the next video, we are going to talk about comparing triangles.